Hello, students. Welcome to the class of radiation. Since 7th class, you have been reading about radiation. It is nothing but energy in transit. So, of different types, electromagnetic radiation is a subject of most concern because most of the energy we get from the sun from outside is in that form. There are various ways of reading about radiation. As we cannot see radiation, we can only feel it. So, we are going into the effects of radiation, the effect that it produces when it is incident on matter. We have already seen how to define radiation, how it behaves under different frequencies and wavelengths in our class on black body radiation. Another effect we have also seen using radiation was photoelectric effect. A third most important effect is the Compton effect. In this effect, X-rays, also a form of radiation, they contain photons, particles. Photons are particles which have no mass, travel with the velocity of light, and have energy h nu, where h is Planck's constant and nu is frequency. So, in the Compton effect, X-rays incident on a crystal collide with it, undergo elastic collision, and the outcoming X-rays get scattered. It's not that they are wholly absorbed, as in the photoelectric effect. When light falls on a metal, it is wholly absorbed and out come the electrons. Here, the X-rays, when they are in contact with the crystal containing lots of electrons, they will collide with one of the electron. One photon will collide with one of the electron, and after undergoing an elastic collision, a part of the energy is absorbed by the electron. The electron comes out as well as the photon comes out, but in a different direction with a different energy, a change in frequency, a change in wavelength. The observed change in frequency or wavelength, that effect is called Compton effect after the name of the scientist. Here we have shown a rough figure of the experimental demonstration. This is a rough source of X-rays falling or streamlined through the collimator and falling on a crystal and come out of the crystal in a different direction from the original direction, and they are detected by a spectrometer, X-ray spectrometer, not the normal one but the X-ray spectrometer. Now in this experiment, exactly in the elastic collision, we will see what happens. Now we are reading all these effects to explain the nature of radiation, what it is like and how it is like. Now coming to the experiment, a beam of monochromatic X-rays of known wavelength are directed, made incident on a target or a crystal which contains electrons, of course. The scattered X-rays at various angles, say phi is the angle of scattering, and that is the value which determines the change in wavelength or change in frequency of the photon. Here a rough figure has been shown. This is the incident photon. It has no mass, only energy h nu. This is the electron inside the crystal. When the photon strikes the electron, an elastic collision takes place. Part of the photon energy given to the electron, the photon gets scattered with a frequency nu dashed. and the electron in a different direction. Here we have shown the vector diagram in which only the scattering angle shown and the wavelength of the photon the h nu dashed by c. H nu dashed by c is the momentum. Momentum, as you know, is mass into velocity. Here the photon has no mass but energy h nu dashed. Energy is also equal to mc square. So mc into c, mc is nothing but mass into velocity. So mc being momentum and c being velocity of light with which the photon travels. So mc square is equal to pc. P is the momentum of photon and c is the velocity of light. So that is the energy part. Mc square is pc. So h nu dashed by c is the momentum here. We'll see later on in the calculations how it is equal to that quantity. The momentum is a vector quantity and it has two components. Say if you call this the x-axis, this is the x component and this is the y component. The x component being h nu dashed by c cos phi, y component h nu dashed by c sin phi. Similarly, for the electron, the momentum is p say, then x component is p cos theta, y component is p sin theta. So after this resolution of vectors, we come to the elastic collision properties. The properties of elastic collision, law of conservation of energy and law of conservation of momentum. According to the law of conservation of energy, total energy of the system, that is the photon plus electron before collision, is equal to total energy of the system after collision. Now before collision, the photon has energy h nu. The electron has a mass m0. m0 into E is equal to mc square, that is the energy of the electron. This is h nu dashed is the final energy of the photon and mc square is the energy of the electron. You remember here that m0 is the rest mass of the electron and m is the mass of the electron when it is moving with velocity v, and E is equal to mc square. A mass m0 is equivalent to energy of m0 c square. So from this equation we will get equation 1. Rearranging the terms, mc square is equal to h into nu minus nu dash plus m0 c square. Here we have shown a different calculation where energy lost by photon equal to energy gained by photon is reached the same equation. Here I have given a note for you for explanation. H nu being the energy of photon before collision, m0 c square electron energy before collision, h nu dashed after collision photon energy, and mc square is the electron energy after collision. Now the elastic collision, as you know, holds the law of conservation of momentum also. So what is momentum? Momentum of photon plus electron before collision equal to momentum of photon plus electron after collision. Now in the note I have clearly given, this is the energy of photon h nu. And also we have seen another formula for energy, that is in the case of electron it will be mc square And if you put m into c, mass into velocity, as momentum p into c. And also momentum p should be written by energy divided by c. Now in the case of photon, the energy is h nu. So h nu by c is the momentum of photon. For electron, the momentum is just mass into its velocity. Again, if you look at the vector diagram, we have resolved the momentum into x direction and y direction. Then we will take first the x direction and get an equation. h nu by c, which is the momentum of photon before collision, and after collision it is h nu dashed by c cos phi. Before collision, the electron momentum was 0 because velocity is 0. After collision, it is p cos theta. This equation gives pc cos theta is equal to h nu minus h nu dashed cos phi. Here we have multiplied the equation by c. Now after collision, this is the y direction, not after collision, y direction. The photon was traveling in x direction, so y direction component 0 initially. Electron was always at rest before collision, 0 is equal to photon momentum in the y direction h nu dashed by c sin phi, electron momentum p sin theta. So this gives p sin theta is equal to h nu dashed sin phi. Squaring equation 4 and equation 5 for simplifying, then you will get here cos square p square c square cos square theta, p square c square sin square theta. So p square c square taken common, sin square theta plus cos square theta is 1. So this is equal to your addition of these two, h nu minus h nu dashed cos phi whole square. So a minus b whole square. And this is the second term in the second equation here, h nu dashed sin phi, h nu dash sin phi whole square. So a minus b whole square we have taken and written square of this. Wherever cos square phi sin square phi comes, those two added together 1, so h square nu square will remain. And once you take h square common, you will have nu square here, you will have nu dashed square here, and you will have 2 nu dashed cos phi. And here it will be p square c square. Now from equation 1, if you see, mc square is equal to h into nu minus nu dash. That also if you square, you will get a plus b whole square. So a square plus 2ab plus b square. So that is what is written here. In a square, you will have nu minus nu dashed whole square. So nu square minus 2 nu dash plus nu dash square will come in this bracket. So simplifying this equation, you can do it yourself separately. M square c to the power 4 minus p square c square. See, you are subtracting 6 from 7. This is equation 6. Okay, and this is equation 7. So you are subtracting. So m square c to the power 4 minus p square c square is equal to, this you will get minus here plus 2h. This will come like that only. This will come same thing. But here you will have h square nu square. And here also there is h square nu square. So they will cancel. And 2h square nu dashed if you take out, then you will get 1 minus cos phi inside the bracket. Just go through the calculation in detail. M square c to the power 4 minus this p square is the momentum of electron. If its velocity is v, you can differentiate between v and nu, I hope. Nu is frequency and v is velocity of electron, c is velocity of light. So this can be written as m square v square c square, and if you take m square c square outside, you will get the same equation. Here I have given the explanation. Here the same equation written, but what happens is when the electron is moving with velocity v, here when the electron is moving with velocity v, then its mass in terms of its rest mass using theory of relativity is given as m is equal to m0 by root of 1 minus v square by c square. This is from the theory of relativity. So you will put the same, for instead of m you will put all this, and instead of m square it will be squared, and here a root will cancel. The left side, right side of the equation will remain same. So here if you take this LCM and all, you will get c square minus v square, which cancels, and c square will come up. So you will have ultimately m0 square c to the power 4, and here same. So this here also m0 square c to the power 4 is there, which cancels with this. And so if you take this one remains and this one to this side, then this equation 2h into nu minus nu dashed m0 c square 2h square nu dashed 1 minus cos phi nu minus nu dashed, yes, 2h will go, 1h will remain here, and this m0 c square coming down, okay, and nu dashed will come here, so that it will become 1 by nu dashed minus 1 by nu is equal to h by m0 c square 1 minus cos phi. This gives you the difference in frequencies which the photon undergoes because of the collision with the electron and getting scattered by an angle phi. Phi can be measured by the spectrometer. Other values are constants. Nu we know, nu dashed we calculate. In terms of wavelength, if we want to do the same thing, then we will see multiply by c here. Remove one c from here and put here. Then you will have c by nu dashed minus c by nu, which is actually c by nu is lambda dashed. Here in the note I have given c by nu is lambda dashed, nu dashed is lambda dashed, c by nu is lambda. So the difference in wavelength is given by this formula. Okay, cos phi 1 minus cos theta I is 2 sin square theta by 2. So that formula has been used here. So this is your change in wavelength of the incident radiation and gives you the Compton effect. Now we have a problem here where an X-ray photon is found to have doubled its wavelength on getting scattered by 90 degrees. So phi is 90 degrees, and once the wavelength is doubled, lambda dashed is equal to 2 lambda. Initially wavelength was lambda, finally it is 2 lambda. So the difference is lambda. And if you place it in the equation, simple problem, if you place it in the equation, you can draw the figure like this, just a photon and an electron, and the photon going 90 degrees. You need not think of the electron in which direction it goes. So the angle is 90 degrees, x component 0, y component is there, and taking the values of h, m0, c all given, you can calculate delta lambda here, and you will get it as something like this much. 10 to the power minus 10 meter is 1 angstrom. Now if you want to calculate the energy formula is h nu. So h into c by lambda. You put lambda value here and find out the energy in joules. And 1 joule is equal to how many million electron volts? You have to divide it by 1.6 into 10 to the power minus 19. 1 electron volt Here I should try to explain. 1 electron volt is the energy required for 1 electron to move through 1 volt potential difference. 1 volt potential difference means 1 joule per coulomb. Work done on 1 coulomb charge is 1 joule, then the potential difference between the 2 points is 1 volt. So for 1 electron to travel, it will be 1.6 into 10 to the power minus 19 joules. So 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So 1 joule equal to 1 joules divided by this much will give you electron volt. A million electron volt means into 10 to the power 6. 10 to the power 6 comes here, but you remove that, you will get million electron volt. Hope I am clear with it. The importance of Compton effect is that it directly points on the particle nature of radiation. Without assuming that radiation consists of particles called photons, we cannot explain this effect. So Compton was successful, and even in photoelectric effect we have seen that radiation has particle nature. Thank you.